Sit wherever you like. Sit wherever you like. Are you serious? Oh. Ooh. Where are you sitting? Sit right here. Wherever you like. He's a creepy little corner. Yeah. I think it's 14.50. He'll give you some cash.
My mom said keep the 50 cents as like interest.
Oh, we're done. Stay wherever. Okay. Stay wherever you like.
Sorry, I get shot somewhere.
Oh, you're gonna?
I was literally almost shot. They cried to make mad at me. Yeah. Like, they all like, you're 14 years old. I love you so much. You're a big deal. I was getting a shot, and I was like, oh, it's like fire. That way. Did we sit anywhere?
Yeah.
Oh.
Okay.
Oh, I thought that's what chapter 5. I was like,
Do I need to buy you
Never mind. I don't want to see my brother. Fine, whatever. I like it though, Bailey.
I'll buy you. It's just from.
No big deal. I don't blame you. I kind of blame you. I don't blame you. I kind of want you too.
Right? I honestly continue to have my cousins. Do you want me to sew them up for you? Do you want me to
then we just
I want them. It's like that. I like it too. Oh my god, no.
Oh, Rachel, we're going to sit last? Rachel, don't sit alone. Come on. Sit with us.
I got it, but I was getting it.
Oh, you did? I didn't know. I'm going to get one of Oh, yeah. That didn't help a lot.
okay. Alright. Hey, remember, today's the last day to get in late work. It'll be turning, it's got to be entered today, so make sure if you have any late work from previous chapters, whatnot, you're getting that turned in. Let's see. Yep, that's all taken care of today. If you notice, we're kind of in a weird situation. You guys are sitting in weird spots. Today, we're just going to take a few notes, and I want you to be able to converse with your neighbors about certain things when I ask you a question. Okay, does that make sense? That's why you can sit wherever you like. All right. So, let's go through a couple things here. Pretty easy notes. And at some point, I'll ask you and your neighbors to converse about a certain topic to see if you guys can figure it out. All right, so we're moving on to chapter 3. That's the chapter we're going into. Just so you know, like you have a heads up of like what chapter 3 is going to bring. It's going to bring all about parallel lines and perpendicular lines. That's going to be our big deal in this chapter. Now, we've already had these words before, but the good news is we're going to do a quick review in these first couple sections, and then we're going to start ramping it up, looking at more and more difficult items. The reason why we need this stuff, we need to look at how to do this stuff with geometry proofs, and this will eventually lead into our shapes, because these objects, they form the basic shapes that we know, like squares and rectangles and triangles, by having these types of figures in them. Okay, so that's the idea. So these are going to be like two of our pictures we're really going to look at hard today. We'll kind of see where we're at. It's pretty straightforward, but I just want to make sure that you understand for this topic today, like what we need. A lot of vocab words today, and that's why I have you in groups so you can like discuss it. You can look at it. All right. So we're talking about this first section is actually called parallel lines and transversals. These are going to be our words we need to define today. Before you leave here today, I want you to know what a parallel line is for sure, like the actual geometry definition, not algebra definition. And then the idea of what a transversal is. Because I think some people have the wrong idea of this. Okay, because we're going to need this throughout the chapter. Okay, all right, here we go. Definitions, lines. A line, because this is our first object, because obviously we're talking about lines today. They consist of 2 points, at least 2 points, right? That extend in both directions without limits. That's a line. We've definitely had some postulates about lines. Like if you think back to the postulates from chapter 2, it was postulate 2.1 that talked about that given 2 points, there's exactly one line that contains them. Or 2.4 or 2.3, sorry, it talks about if you have a line, there's at least 2 points on it, that type of thing. But a line, 2 points are on it, extends in both directions without limits. That was from the very first section of chapter 1, chapter 1.1. Okay. The other word that we need to discuss is the idea of planes. A plane consists of 3 non-collinear points, so 3 points not in a straight line, which extends to have no edges. So I know that the book always draws these terrible pictures of planes that look like pieces of paper, but you need to remember they have no edges. Planes extend in all directions without limits. They don't stop. It's like a line, right? You can't put arrows on a flat surface. It looks goofy. And again, that was from that first section. We've also talked about a couple of postulates, postulate 2.2, postulate 2.4. Talking about 2.2 was like if you have 3 points, there's exactly one plane that contains them. And 2.4 talks about if you have a plane, there's at least 3 points on it. The big word was non-collinear, not in a straight line. That's what that means, not in a line. All right. Questions with those first couple vocabularies? We've already discussed those, so they should be like nothing new. That was just kind of a lead, right? All right. Now today, let's talk about what parallel means and skew. Those are two topics that they're complete opposites of each other. They're negations of each other. So let's start with a parallel line. Okay, now in algebra class, think about what parallel was from algebra. Parallel lines in algebra class were lines that had the same slope, if you can remember that. Right? That's what algebra always talked about. When you're looking at like slope-intercept form of lines, you had a slope, you had a y-intercept. Well, parallel lines had the same slope. Geometry is a little bit definition. There's a two-part definition for parallel. The first part, they had to be coplanar. So the lines actually have to be on the same flat surface, or be able to be contained on the same flat surface. So I'll show you that idea that they could be on the same flat surface in a minute. And then the second part is that they can't touch, they can't intersect. So they do not intersect. Highlight the word not. But again, they have to be on the same flat surface, not touching. So like when I start drawing lines on my marker boards, hopefully they don't touch. Now here's my example. Now there's 3 lines on this picture. There's 3 lines. There's line JL, that line. There's line JK, and there's line LM. 2 of them are parallel. So discuss amongst your group right now. Take 2 seconds here. Which 2 lines are the parallel ones on that picture? It should be like 2 seconds to figure that out. Alright, so group up here. First line that you think is parallel. One of the 2. JK. I like it. Alright, so JK. Now, when we write a line, it's got to have the 2 points. Got to have the arrows above it. So there's one. That was good. Next line that's parallel to that one. So this group right here. LM. Okay? LM. These 2 lines are the parallel ones. Now, how we show that they're parallel, it's actually this little marker right here. The little arrow marker tells it they're parallel. Sometimes they're just little like actual arrows. If there's multiple lines that are parallel, they'll all have that. Now there is a symbol for showing parallel. They're really long, tall bars. They're kind of italicized. I'll show you that later. We'll actually discuss that later in a later slide. But this symbol means that the two lines are actually parallel. The difference between parallel and perpendicular, which is in this chapter. Perpendicular symbol is this one. The upside down T. That means that they make 90 degrees. They make a little T intersection. Okay, so there's a big difference between being parallel versus perpendicular. These are parallel. They're not touching. They're on the same flat surface. Okay, questions with the first one? Okay, we'll probably come back to that picture later. It's just kind of easy to look at. But that's kind of our first word. Now, obviously, from algebra class, they do have the same. Slope. Okay, these are actually horizontal lines, so the slope would actually be 0. Okay, now the other word that I want to discuss is the word skew. Okay, skew is almost like the negation of it. It's a complete opposite. Skew lines, there's two parts to this. They're non-coplanar, so that means they cannot be in the same flat surface. But they're not parallel, nor are they intersecting either. Alright. So they're not parallel, but they're not intersecting. Now, a lot of people, when they read that, they're like, God, how is that even possible? They're not touching, but they're not parallel either. And the reason why is that because they're not on the same flat surface. So let me give you a picture here. So here's my little picture, my little cube. What I would like in your groups, I'll give you about a minute for this one. All I need is two lines that are skewed. So they're not parallel, they're not intersecting, they don't touch, and they're not on the same flat surface. So in your group, you need to come up with two lines that don't touch, and they're not parallel either. And they're not on the same flat surface. Okay? Take 1 minute right now. Maybe a minute. And I'll let you know right now, there is a ton of options. There's a ton of options. Not just one, there's a lot of different ones. So if your groups around you are saying different ones, don't worry. Yours could still be correct.
Okay.
It's weird. So they can't touch. They're not parallel. No touching, no parallel. So we got some time. Okay, so got about 10, 15 seconds here. All right. So I'm going to walk around. I'm going to grab an example from your group. We're going to discuss it as a whole. So I'm going to start over here. Your guys' group. So I need two lines that you think fit this definition. Even if you're right or wrong, throw them out there. Okay. AH. Okay, that's one line. If you don't know where AH is, it's that bottom wall right here. It's this bottom line.
And
Say it again. FG. FG, and that is this one. Going up and down. I can tell you right now that is a perfect example of skew. They're not touching, and they're not on the same flat surface. So AH, FG if I were to hold up markers to kind of represent what's happening here, so here's AH, here's FG. You can definitely tell no matter how I move them, they're not touching, and they're not even on the same class surface. They're going different directions. Does that make sense? There's a space between them, and they're going different directions. So they're not, if they're parallel, they'd be doing this. That's parallel. So it'd be like these two. These are parallel. Or the one in the back and this one. These are parallel, no matter how you hold them up. But skew means they have to go in different directions, however you hold it. Okay, so that was a good example. All right, so another example. What do you think? So group in the middle here.
CB and EF.
So CB, and what was the other one? EF. EF. So let me draw these. So here's CB going that way, and EF. Yes, those are perfect examples as well. Okay, because it's that same situation. EF is in the back like this. CB's in the front. They're going different directions. That's perfect. That's a perfect example of skew. They're not going the same direction. They're on different surfaces. Okay, back in this corner over here. Do you have a different one? Okay, what do you got? Say again. EC, and BG. Okay, yeah, those are good examples. DC is right here, and BG is down here. So that one's kind of coming at us, and this one's going horizontal, so it's kind of like this situation. That's good. That's definitely skew. They're going different directions. They're not even close. Okay, so we have 3 examples there. There's plenty more on that picture.
I have a question.
Yes.
Does it have to be a drawn line?
That is a good question. Technically, no. So you got one in mind? AF and BH? Yeah, that'll actually work. So that's actually a really good one. AF and BH. So AF is going up this way, BH is going this way, so they're going different directions. That's a good example of skew. Because remember, if you remember back to chapter 2, we can start drawing our own lines now. So that's actually a really good example. So there's a lot of possibilities here. They just cannot touch, they have to go different directions. That's skew. Skew is one of the weirdest concepts to try to explain to somebody without like showing like an example of going different directions and having space between them. Okay, so we have a ton of examples. This is actually really creative. I didn't even think about it. All right. Questions, comments on the 2 words? It seems like we got a pretty good handle on this right now anyway, but we're starting with it. Okay, now we're going to apply the same concept, but now we're going to do this for planes. So flat surfaces. So we can apply this word like parallel to planes as well. So parallel planes, they are planes that do not intersect. They do not intersect. Now notice I didn't say they didn't have to be non-coplanar. Well, duh, they're 2 different planes. They're automatically non-coplanar. But they cannot touch. So I'm going to go back to that first slide that I did to show you a picture of what parallel is. This is on that first slide that we had that showed us kind of the chapter. These planes, this is plane A and this is plane B, they are parallel. They're flat. Now here's the crazy part. There is no such thing as skew planes. Skew planes. There's no such thing, which is weird. So you're like, how's that even possible? They can't have skew. Because skew means that they're on different surfaces, but they'll never touch and they're not parallel. Well, planes go forever. It's not like a line, right? A line's very like singular, straight. Planes are like this vast, flat surface that extends in all directions. So it doesn't matter how you tilt planes, at some point they'll either have to touch somewhere down the road, or they have to be like this. They have to be parallel. There's no other option. There's no option for skew. Doesn't matter how you tilt it. At some point it'll hit the other one. Okay, now for parallel, I do want to show you the symbol for this. So, and this is another example. I can have lines and planes actually be parallel to each other. So this plane and this line up here, line L, are actually parallel because they're on 2 different surfaces. They're going in the same direction. They're not touching, right? And two segments are not parallel if the lines contained are not parallel. So I'm going to give you an example of this idea of like segments that are not parallel. It'd be like these two right here. Imagine this line A and this line B. Do you see how they're like tilted towards each other? They're most definitely not parallel because when you extend them, even though it looks like they're not touching, right? Like you can see there's like a weird space between them. What do the arrows mean? Go on forever. So that means they'll eventually hit probably in about right in that area. So they're not parallel. Even when you draw segments, and segments, have a starting and stopping point. Like this. A starting and stopping point. Do the segments touch right now? No. But are they parallel? No, because parallel only applies to the word lines or planes. So the idea is that what you have to do to see if these are actually parallel to each other, you have to make them lines like that, where you put arrows on them. So I'm going to put arrows on this, and put arrows on this. Now, are they going to touch? So they'll eventually, those are not parallel. So those are the different setups for parallel. But again, planes can be parallel, they just can't be skewed. That's a different situation. Okay, questions on the three options that I've kind of showed you here. Eventually, I think we're going to come back to this picture later to talk about this figure, like the lines itself. But let's actually get to that parallel symbol because I do want to show you that. All right, so for the parallel symbol, so notation for parallel, it's the two vertical bars, it's these little bars, and you put them in between objects that are actually parallel to each other. So let me give you an example here. So here's my picture again. So I can say that plane A is parallel to plane B, and then this is the symbol that I use. So plane A is parallel to plane B, and notice I'm using the little vertical bars. I could even say, like plane B is parallel to line L. That type of thing. So lines and planes. Now, the problem is I can't say that L and M are actually parallel. Why can I not say that L and M are parallel? They go in the same direction? Yeah, they're on different planes, so they can't be parallel. Planes, are on the same flat surface, right? So these lines in themselves would actually be skewed compared to each other. They're on different flat surfaces. Because if you go back to the definition of parallel, coplanar, not touching, for lines. Let me go back to the definition for lines. All right, questions, comments on the notation, the bars. I'm going to use that a lot throughout the chapters, especially in like tests and other things. All right, so here's the good news. We've basically got through all the definitions. The only word we haven't discussed today, which I said I wanted you to know, is the word transversal. That's one of the words we need to discuss. But is there any questions with like parallels, skew, lines and planes, that type of thing? Or segments? Question? Okay, now here's the thing. I did put it in groups for reasons today. What we're going to be looking at is, we're going to be looking at examples of different definitions for when you have lines that are parallel to each other, or when you have lines that are, skew, or they intersect, they cross each other, that type of thing. So you have intersecting lines. We have a bunch of vocab terms that apply to these pictures. Okay, so there's like little vocab terms. So that's what we're going to discuss today, and I'm going to have you guys discuss certain things with yours. Okay, so here's the words I want to discuss today. Okay, these are going to be words that we can use for the future for parallel lines. They can be used for lines that intersect. They can be used for other purposes. But for this, these are the words we're going to discuss today. So I'm going to go through the list. So here's a picture I'm going to use for right now. So we have a bunch of lines here. We have line R, S, T, V. We have a bunch of angles in there, 1, 2, 3, 4, 5, 6, all the way up to 12. But here's the words I want to discuss. I want to discuss the word transversal first, like what a transversal is for this picture. I want to discuss interior angles, exterior interior angles, alternate angles, there's different types of alternate angles, by the way. Same side interior angles, there's a couple different types of those, and corresponding. These are the words I want to discuss today. Now, obviously, eventually we will get back to this picture to see if, like, you understand how these words apply to this picture. That's what we're going to get to. Now, what we're going to do is we're going to try to go through these words one at a time. That way you know exactly what I'm talking about. All right, questions on what we're going to discuss for the next couple slides. This is kind of like our goal right now. Let's see how many words we can get through. If we don't get through them all, that's fine. We'll continue tomorrow. Okay, because we're going to take our time to make sure that you know it. That's why we're in groups you can discuss when I give you definitions. Okay, but again, I'm going to get away from this picture. This picture is difficult. There's a lot of things happening here. We'll go to like a simplified version of it. Okay? All right. So let's discuss the first word. Let's talk about transversal, but let's make this picture a little bit easier. So, okay, for the word transversal, here's the definition. It's a line, segment, or ray, so it could be any type of line, if you think about that intersects two or more lines. So it's the line that crosses two or more others. So I'm going to give you a picture here. So I give you a picture. I want to know, out of the three lines that are on this picture, we have line T, Q, and R. Which one, there's one of them, is a transversal? So discuss amongst your group, which one of the three is the transversal in this picture? So I'm betting on you probably already figured it out. But I want to know, by definition, if it's a line, ray, or segment that intersects two or more others, which one's the transversal? So I'm going to start in that back group. So Hannah, your group back there. Which line up here, which one of the three is actually transversal? Right now. Like it hits two or more others. T, you're absolutely right. Transversal is letter T. Okay? Because T, if you look at the line, it's hitting two or more other lines. Now, the other thing is, it was kind of a trick question. Now, all eventually will hit all the other lines. Because if you notice, these are like actually tapered together. They're like pointing at each other. So eventually, Q will run into line R. R will run into line Q. So in fact, every line up here is actually a transversal at some point. Because they'll hit two or more other lines. Yeah. Yeah, it's kind of weird how that works. I just pick random lines of paper and stuff. Okay, but the main one that you can like visualize right now, definitely line T. That definitely hit two others like right now. So that's why it's a transversal. Okay, questions, comments on the first word. So again, hopefully by today you know what the definition of parallel means by geometry. Same planes do not intersect. We know the word parallel planes, where they don't touch. We know skew, the idea of skew, and this idea of transversals, lines that touch, they intersect, two or more others. Now, by having this picture, now we have a bunch of different type of vocab terms that come up with this. So we're going to stick with the same picture for the next couple of vocab words. So if we went back a slide and we looked at all the words, we had, transversal, interior angles, exterior angles, alternate angles, we had same side interior angles, corresponding angles. So we had a lot of different types of angles. So the first type we're going to go into, let's go into interior angles. Okay, so they're angles that are on the inside or interior of horizontal lines or vertical lines. I just put horizontal here because that's the picture I'm going to show you. So they're angles on the inside or quote unquote the interior of the horizontal line. So they're in between two lines on this. So I'm going to show you the picture. So does everyone see that I have, horizontal lines? These are kind of tapered together. Same picture I just showed you a little bit ago. These are my horizontal lines. So what are the angles on the inside? Can you number them off? 4, 3, 5, and 6. Those are your angles, 3, 4, 5, and 6. These angles are on the interior. That's why I color-coded that. It's green. And it's actually, you can label. Okay, these angles are on the inside of the parallel, or on the inside of those lines. Okay, now, even if you, like, turn your head sideways, and you look at it from a different perspective, it's still true. They're inside of two lines. The lines can be tapered, they can be parallel, it doesn't matter, but they're squeezed in between. Those are interior. Okay, let's go to the second one. Exterior angles. Exterior angles are angles that are on the outside of the actual horizontal lines or vertical lines, however you're looking at that picture. So I picked the horizontal, so I'm going to use that same picture I just did a little video. So exterior angles are on the outside of the two lines. So what are the numbers for the exterior angles? 1, 2, 8, and 7. Those are the exterior angles. So I kind of color-coded them. All right, any questions with the vocab terms so far? All right, they're pretty easy. The idea is that I've labeled interior, labeled exterior. Now, what we're going to be going into, and why I brought this up, is because there's a relationship of these angles. That's what I want you to know. Certain angles up on that picture, or if these lines are parallel, by the way, if the lines are parallel, okay, which they're not in this case, but if certain lines are parallel, certain angles on this picture would actually be equal to each other. Okay? So that's what you need to realize. That's what we're eventually going to get into. Today it's just to discuss the words, like which word is which angles are which. Eventually in this chapter, chapter 3, we'll eventually say like, hey, since these lines are parallel, these certain angles are equal. Hey, you know, in this picture, certain angles are equal. Right now, the only thing we can tell from this picture is that we have vertical angles. That's really the only thing I can tell you. Like up here, which angles are vertical? Give me a pair. Give me a pair of angles that are vertical. They're funneling to each other. 1 and 3, 2, 4, 7, 5, 8, 6. Right now, we know that those angles are equal. Okay, just because they're vertical, they're straight across. Okay, so we also know that certain angles there add up to be 180 because they're a linear pair. You know, 2 and 3 or 5 and 6. They're a linear pair, so they add up to be 180. Because of that, you know, that theorem 213 that we had, or supplementary. But eventually, we're going to come back to this. All right, questions, comments on the words so far? I think these words that we've discussed so far are fairly straightforward. They're fairly easy. The words we're going to go into, like the later ones now, these are not easy anymore. So that's what we need to make sure of. I thought this was simple. Exterior, interior. Okay, so the next word. It's called an alternate angle. Now, there's different types of alternate angles. That's what you need to realize. We're going to discuss the generic type. So, definition. Angles that are on the alternate side of the transversal. They're on the alternate side of a transversal. That's the generic definition. Now, there's a couple of stipulations to these certain types of alternate angles, but this is the general, the most generic way I can explain it to you. They're on alternating sides of the transversal, so opposite sides. Now, so here's my picture. I'm gonna go to this simple picture, not that super big, complicated one I showed you earlier. Okay, so angles that are on the alternate side of the transversal. Now, I'm gonna label these lines up. So I'm going to label. So let's call this line L, M, and N. Now, out of those three lines, which one's the transversal? Right now. Is that it? Line L. Okay. Line L right now is the most obvious one. That's the transversal. It's hitting the other two. Trick question. They all are transversals, correct? because they'll all eventually hit each other, so that each line is going to hit two or more. But the obvious one right now is that line L hits the other two. Okay, so we have our transversal ahead, the one going horizontal. Now, alternating angles are angles that are on the opposite side of the transversal. So I need a pair of angles that are on the alternating side of the transversal. Give me any pair you want. 1 and 5, those are alternating. They're on the opposite sides. Give me another pair. 3 and 7, give me another pair. 4, 8, give me another pair. 2, 6, give me another pair. 5, 6, not 5, 6. 2, 5, those are good. 3, 8. 4, 7. 1, 6. They're on alternating side of the transversal. This is the transversal. So you can pick any pair. You could even say 1 and 8, or 4 and 5, or 2 and 7, or 3 and 6. Do you see how they're on opposite sides of the transversal? They don't even have to touch. They just have to be on the opposite side. So I'm looking at this as the transversal. So you're just picking one on the top, one on the bottom, basically. Does that make sense? Now, if you turn your head sideways, then you got to kind of look the other direction. So you got to figure out where your transversals, pick ones on the opposite sides. So again, angles could be like 6 and 3, 7, 5 and 4, 1, 8. These are just rough examples because there's a ton of different ones. Now here's the problem. I want a certain pair, not just any random ones you want to pick. So now here comes the hard part. This is the part where you're going to need to add this in by yourself. Okay, so this is going to be the part where you're going to have to add some stuff in. I want to talk about alternate interior angles. Alternate interior. So we have to think about what interior means. So here's your stipulations. Alternate interior. They have to be on the alternate sides of the transversal. This has the word alternate in it. They have to be interior angles. Because obviously it says alternate interior. Now here's the other stipulation. They are not adjacent. That means adjacent means they cannot simply touch each other. That's this. This is the very specific type of angle called an alternate interior. So can somebody give me an angle, or a pair of angles, I mean, that are on alternating sides of that transversal, which is line L, like you said earlier. They're on the interior, and they are not next to each other. So where we got 2 and 7, perfect example. That's alternate interior. 4, 3, 6. They're on the inside. The inside angles are the ones in here. These are the interior. They're inside the two lines. So these are the interior. Alternating means they have to be top and bottom, but then they can't touch, so it has to be these two. These are the pairs. Okay, those are called alternate interior. Now, the other type of alternate angle is the alternate exterior. Alternate exterior, the only difference would be I need exterior angles. So they're alternating sides of the transversal, they're exterior, and they're non-adjacent. They're not touching. So can somebody give me a pair of alternate exterior? 4 and 5, 1 and 8. It can't be 1 and 5. Those are touching. Those are adjacent. But the exterior angles are these two and these two. But the alternating ones are the ones diagonal. They're alternating sides and they can't touch each other. So I can't pick 1 and 5, so I have to pick 1 and 8. Okay, does that make sense for alternate exterior? Remember, the hard part about this whole concept is knowing where the transversal is. Okay, question. Where the transversal is, and then understanding where the interior and exterior angles are. So you got to know like where the two lines are. That tells you where interior versus exterior are. Even though I turned the picture sideways compared to what I showed you earlier. Okay. Questions with alternating. Okay, let's move on to the next word. Next word. called same side interior. So now this is pretty straightforward. There are angles on the same side of the transversal, and they're interior to each other. So, showing you the same picture. Here's L, here's M, here's N, just like before. I need angles that are interior, and they're on the same side of the transversal. So, I need a pair. 2 and 3. These are on the same side of the transversal, and they're on one side, and they're in the interior of the 2 lines. So those are same side here. What's the other pair? 6 and 7. Okay. So 6 and 7 would be the other pair. So those are same side interior. So again, angles 2, 3, 4, 6, and 7. Okay. Questions on same side interior. Now there is such a thing as same side exterior. I didn't put it in the slides because it's pretty straightforward and obvious. If I want same side exterior, what would those be? 1 and 4. These are same side exterior. They're on the exterior angles. They're on the outside of the 2 lines. They're on the same side of the transversal. So 1 and 4. Okay, we'll eventually talk about how these angles work. Is there a weird, quirky relationship between all those angles? All right, and that's what we're going to get throughout chapter 3. All right, let's keep going though. So that's same side. The last word that we need to discuss is called corresponding. Now, I don't know if we'll finish this one today. This is one of the hardest words to try to explain to somebody. Corresponding angles. All right, so they're angles on the same side of the transversal. So keep that in mind. Same side, but now there's a stipulation. One has to be interior, one has to be an exterior for it to be corresponding. So one interior, one exterior angle, but on the same side of the transversal. And the other stipulation, they are non-adjacent to each other. Non-adjacent. Okay, so let's go back to that same picture I just showed you a little bit ago. I want 2 angles, just a pair, that are on the same side of the transversal. One's interior, one's exterior, and they're not touching. That's what makes this one difficult. It's the hardest one to explain to somebody. Say it again. 1 and 3 is a perfect example. Angle 1 is exterior, angle 3 is interior. Do you agree that they're not touching? And they're on the same side of the transversal. So perfect. Give me another pair. 5 and 7. That's a good one. 5 and 7. One's exterior, one's interior. They're not touching. They're on the same side of the transversal. Another pair? 6 and 8. Or 2 and 4. All right, so there's your pairs. 1, 3, 8 and 6, etc., etc., etc. For some reason, this is the hardest one to explain, especially when I switch the picture. Okay. We'll discuss more on Monday. Monday, when you come in, your desk will probably be like this again. So just kind of sit wherever you want. Okay?
I need to know is these reflexive verbs that start and there and I always forget. I always forget. I know that one.
Somebody want to hit the lights on the way up, please?
I always forget.
Thank you.
Ray Cataldo, Page Meters, come to the office, please. Ray Cataldo and Page Meters.
bag is so heavy right now. Why is that? Forever.
No, I'm supposed to. I'm relative left, but.
Not gonna lie.
You guys are here.
It was literally
I'll just sit in my office.
Oh, God.
Where do you go? Oh, that's where
Nice.
Yeah, one, yeah.
Nick?
Does he group us up or do we?
No, when you were gone, we
We're
grew
all
up.
just kind of sad.
Okay, whatever.
Thanks for sad, Cassie. After I helped you today.
Yeah.
I wasn't sure which one. Guy. I said,